Okay, hi everyone. My name is David DeKime, and this is the first intermediate milestone assignment for our educational technology class. So first, I just want to quickly talk about what my project is. I'll kind of go into the user interface that I've created thus far, um, show some of the functionality of it through a video, talk about some of the issues that I've encountered thus far, and then talk about where I'm going with this ultimately. So my project is ultimately to develop a mobile augmented reality app for iOS devices, namely iPhone, iPad, that is going to simulate some common path planning algorithms. Due to the nature of this class, where we only have a few weeks to really implement this, I'm kind of laying out some of the minimum viable product things. So it is going to be a multi-screen application. It's going to have sort of a main menu where you can select the type of search algorithm you want to see or simulate, and then it's going to send you to an AR interface screen. Um, on that screen, you'll be able to select start and goal points, as well as obstacle points like walls to be avoided when the path is generated, and then the actual simulation of an A star, at the bare minimum, A star search algorithm that will have sort of a 3D visualization using virtual objects that are overlaid on a real world environment. So this is the user interface that I have so far. So the main menu, you'll be able to select your search algorithm. For starters, I just kind of made these scrollable lists. So this includes, breadth first search, Dijkstra's, and A star. And then if it's applicable, you have a heuristic to choose from. So like Euclidean distance, Manhattan distance, which really only apply to A star in this case. Down at the bottom is the Simulate Path button, which sends you to the AR screen. So on the AR screen, uh, you're going to point the camera at a flat surface, and then a ground plane is going to be detected. And on this ground plane, a grid image is going to fit to the extent of the ground plane, the length and the width of it. And then there are also these spheres, which are going to act as the discretized points for the path planning algorithm because these positions are known. And they are spaced out about a 20th of a meter all the way to the length and width of the ground plane itself. Obviously, for different ground plane sizes, you'll get fewer number of points or more points. And sometimes the tracking is kind of strange due to lighting conditions, etc. So there is a reset plane, which basically resets the tracking so you can set up a ground plane on a different surface or just in a different position. So this works sort of like this. Here's the app in action on my phone. There are two scrollable lists here, so you can search. You can get your search algorithm. So let's choose A star. So for our heuristic, you've got Euclidean distance, Manhattan distance. So we'll select Euclidean. Down at the bottom, there's that Simulate Path button, which is going to send us to the AR screen like this. So the ground plane's been detected, but the tracking is a little funky due to the lighting conditions. So we can hit Reset Plane. Retrack it. There we go. Okay, so a better ground plane. You see all the points. The closer you get to it, the more detail you can see. And then on a smaller surface, you can see we'll have fewer points, something like this. There we go. Smaller ground plane. Again, the closer you get to the plane itself, the more detail you can see in the 3D objects. Okay, quickly talk about some of the issues I encountered. So originally I thought that the ground plane detection provided an AR kit would give you a set of discrete points that you can access, but you really can't. It's pretty limited. Um, it's sort of a continuous plane, and you need, for any path planning algorithm, a set of discrete points. So I've created a series of 3D virtual sphere objects that basically are at known positions on the grid and have some known geometry, so I can use that in any path planning algorithm. I was also planning on using vertical plane detection to detect any sort of objects in the environment and be able to use those as like walls. Um, Turns out vertical plane detection doesn't actually work that well. Uh, so instead, I'm going to make it so that the users can tap spheres that they want to make walls or obstacles, and those will ultimately be routed around when the path is generated. Um, Lastly, in going forward, I plan on allowing the user to tap any sphere they want as a start point, tap another one as the goal point, and then again tap any ones that they want to create walls that can be routed around. I'll have to implement a priority queue, especially for using A star. And then I will use a 2D array of these sphere nodes because they have known positions, and I'll know where the start is and the goal is based on the user selection to generate the A star path. And I'll illustrate that path and then provide access to the user to see some of these path parameters. So thanks for listening. That's all for now.